The class. So, yes, yesterday we studied about what? We started pharmacokinetics. Basically, we had a very beautiful introduction of pharmacology. Then we dealt with what? Administration of the drug. We discussed what are drugs, how do we administer a drug, what will be the form, what will be the route, isn't it? And then we said what is pharmacology? Nothing but the interaction of drug and body. And when the drug, what does the drug do to the body? What we say it as pharmacodynamics. Whereas when we talk about what the body does to the drug, what we tell it? We tell it as pharmacokinetics. And this is what we were discussing in the last class. We said whenever the drug is coming to the body, whenever the drug comes to the body, what we have to say? We have to say it whenever the drug will enter the body. What do you have to say? You have to say adab. Adab, that is ADME, not exactly adab but ADME, to remember. That is absorption, distribution, metabolism and excretion. And we saw the different ways of absorption, how the drugs get absorbed and where the drug gets absorbed. I'll give a quick review of where and how the drug gets absorbed. So if we talk about how the drug gets absorbed is by the transport, isn't it? So we studied about passive transport, about the active transport and the special movement. So this is how any drug is getting absorbed, either simple diffusion or facilitated or carrier by through a carrier, or by spending some ATP, or by co-transporters, isn't it? As well as there were such special movements through which a drug was getting absorbed. And what was absorption? Let's see that whether you remember that or not. What is absorption? Absorption is nothing but where let's suppose this is the administration site of drug. Okay, so transport of this drug from the site of absorption to the bloodstream, this is absorption. And we saw different ways. That was the way of transport, isn't it? And what is this? This is the way of transport. We saw how it gets transported, and this is where, from where it gets transported, isn't it? From where? So we discussed about the GI tract, the main tract, mostly from where the drugs are getting absorbed. If we are giving through an enteral route, I hope you didn't forget what are enteral routes. ORS, the oral, rectal and sublingual. Okay, the next one, parenteral, if we are giving, then it will go directly into the bloodstream. The through the lungs, if we are giving, then it will go through the mucous membrane. And tropical, if we are giving, then also it will go it through the dermis. And a very beautiful mechanism or metabolism we studied, that was first pass metabolism. First pass metabolism. What was that? When the drug was getting counteracted by the liver was just cutting it down and breaking it down, because of which what was happening? The bioavailability was decreasing. Whereas when a drug bypasses this metabolism, what happens? The bioavailability will be increased, because it will be directly going into the systemic circulation and not in the portal vein first. Okay, so this was all about what we discussed in the previous lecture. Now today we will be discussing about distribution of the drug. I think we have started this distribution, but still, let's see. Okay, so what is distribution? Distribution is nothing. Let's suppose that if this is the site of administration, okay, then where we took it into the bloodstream. Now from this bloodstream up to different places, if the drug is going, then this is called distribution. And that's why as you can see, it is forming a pattern of scattering, isn't it? A pattern of scattering. That's why distribution is also called pattern of scatter. It is also called pattern of scatter. Okay, so now the thing is, although the we are saying that the drug from the site of administration going to the bloodstream is what? It is absorption. Whereas from the bloodstream to the local sites where it have to work, this is distribution. Now it has a barrier to cross in order to reach the other sites, and we are about to study about these barriers. And we discussed there are three barriers mainly, that is plasma, protein barrier, the first one. The second barrier, we all of us know, blood brain barrier. And the third barrier is placental barrier, of course, seen in women's. Okay, so we are going to discuss about three barriers: plasma protein barriers, blood brain barrier, and placental barrier. Now the thing is, if this barrier is there, of course, what this drug have to do now, it is going to pass from blood to different tissue right now, right? So definitely there will be factors that are going to determine that how much this drug will be distributed to that particular part. Let's suppose that this is your bloodstream. This is the bloodstream. Okay, this is the bloodstream in which the drug is there, and this is the tissue near which it needs. And okay, so from the site of administration, now the drug came here, and now this drug needs to enter to the tissue, right? Now it needs to enter to the tissue. Now there are factors that are going to determine whether how efficiently it will get distributed. What are those factors? The first one is lipid solubility. Whenever it comes about transferring, definitely we will think about what is the constitution of the drug, whether the drug is a water soluble drug or it is a lipid soluble drug. So we know very well, if the drug is lipid soluble, what will happen? It will get absorbed, it will get distributed into different cells very easily, isn't it? Now another thing is ionization. We'll be seeing it, like how a drug when get ionized, it becomes very easy to excrete it, whereas if the drug is non-ionized, then it gets stored. We'll see all of this, don't worry. Okay, now the third thing is vascularity. When a drug whenever an organ or a tissue is more vascular, what will happen? It will transfer more blood, more blood, more drug will be there. Okay, so this thing is there. The next one is what? Binding capacity to plasma. Binding capacity to plasma protein. Now this is the part we need to, like, think in detail what it is. So we will be discussing about plasma protein barrier, how it is a buffer system and what actually happens. Okay, so let's see. So let's suppose that we have a drug. Okay, this is our drug. Okay, now this drug is, wait, okay, this is the drug. Okay, now this is an acidic drug. Okay, we know either the drug can be acidic, it can be basic, or definitely it can be neutral also. But we will deal with acidic and basic drug. Let's suppose this is an acidic drug. Then you know what happens whenever this acidic drug will come into blood. In blood, what is there? Proteins are there. Plasma proteins are there, right? The protein named as albumin, the protein named as albumin will join with this drug, acidic drug. Okay, which one? The acidic drug will get joined to the albumin. Okay, now what happened initially when it was not combined? When it is not combined, let's suppose this was your acidic drug, and now the drug has been attached to the albumin. So what is this? This is your free drug. This is your free drug, whereas this is what? It is a bound drug. It is a bound drug. Now a free drug is always active. A free drug is always active, whereas a bound drug is used mainly for storage, is mainly used for storage. Now, a question might arise. Let's suppose that I have given a paracetamol, okay, to a patient, and that paracetamol, let's suppose that it is acidic drug. Okay, so okay, not suppose. Okay, let's suppose that that paracetamol hasn't bind to any protein. Now it is in free state, so it will act as an active drug. Then what is the use of making a drug as a bound drug? Why this drug is becoming a bound drug if it is not active? Why we are trying to make the drug deactive? So actually what happens, this plasma protein barrier acts like a buffer system. How it acts? It acts like a buffer system. Why? Let's suppose once there are in total 10 units of drug given. Okay, 10 units of drug were given. Among this, 8 units became bounded drug and 2 units were free drug. So till this 2 units will work, what will happen? Once this will finish, this 8 will again get converted into 2. Then again, when this will finish, then it will get converted into 2. So this is how beautifully the body is trying to not let toxicity happen in the blood, okay, in the body. Okay, because if a drug is trying to retain in the body, that is what we call toxicity, and that we will learn in metabolism and excretion, that how when a drug doesn't get excreted, it becomes toxic in the body. Okay, so I hope that this is understandable, that what is a bound drug and what is a free drug. So whenever you are taking any medicine, that medicine is going into your buccal cavity, then into the stomach, and through the stomach it will go into your main blood stream. And once it reaches the main bloodstream, over there we have proteins. Okay, the plasma proteins. These plasma proteins will bind the drugs. Accordingly, the plasma proteins will bind the drug. Let's suppose if I said that, as if the drug is acidic, then it is getting binded to what? It was getting binded to albumin. What if a drug is basic? Let's suppose that a drug is basic in nature. This is a drug, it is basic in nature. Then what will happen? Then another protein will bind to it. And what is that protein? That protein is alpha acid glycoprotein. Alpha acid glycoprotein. And again, this drug will be in two forms. Again, this drug will be in two forms. Either it will be a bound drug or it will be a free drug. Okay, it will be a free drug or a bound drug. Again, active one and the one which is intended to be stored. Okay, now why we need to understand this thing, that this drug is getting binded to protein. The first thing is excretion is necessary. Okay, we will learn in excretion part that why it is important. Another very important thing, I hope that like you can relate to it. So I'll tell. See what it is. Let's suppose that you have you have given a drug to your patient. Okay, but that patient is not giving any particular result for that. Now there can be possibility of liver metabolism. Like there are possibilities of that his or her liver metabolism has decreased. What will happen if the liver metabolism decreases? What will happen? Definitely the protein, the albumin and the other proteins that the liver make, what will happen? That will be decreased. That will be decreased. And once it decreases, what does that mean? There will be more free drug. There will be more free drug. Now the thing is, if more free drug is there, then what it means? It will be acting more. But in that case, the receptors, it doesn't mean that if more free drug is there, the drug will be very very efficient. No, the receptors has a limit, it has a threshold. Up to that reach, if the drug is there, it will work. After that, it doesn't needs. Even if it is excess, it doesn't even recognizes it. Okay, so when it is very much free, the drug is free, then what happens? This causes toxicity. This causes toxicity. Okay, so I hope that it's clear. And this part can be correlated to like ayurveda very beautifully, that how if this function, the metabolism is not happening, if pitta enzymes are not happening, then why the ama or things are produced. Okay, we won't go into that detail, but just this was a very beautiful thing that can be understood, that how even if you are giving a drug, it won't going it is not going to affect, but it will only cause toxicity. Okay, so I hope that this part is clear, what is plasma protein barrier and how it acts as a buffer system. Okay, so see, now there are other tissues also that are involved in this distribution part. The cellular, the fat, wait, I'll just take, yes, the cells also act for the distribution part, isn't it? Like I2, the iodine in thyroid, it's helpful over there. Whereas if I talk about If I talk about fat, then adipose tissues are helping in the distribution. Whereas if I talk about transcellular, then aqueous humor in CSF is acting. Whereas, who is this? Okay, okay. I'll try to decrease my speed. Okay, okay, okay. Okay. I'll just try to decrease my speed. Okay, yeah. So we were dealing with what? We are dealing with distribution. In that we saw that there is always a buffer system between the free drug and a bound drug. If the equilibrium is maintained, then it's good. But if it doesn't get metabolites or excreted the drug, then what will happen? There will be high ppb drugs, and it will be like definitely toxicity will be there. Okay, so this was all about distribution. I hope that it's clear. Yeah, the fifth part. So it's not only the cells, it's not only the cells, it's not only the fat, it's not only the transcellular part, but also bone and connective tissue. Bone and connective tissue also helps in that. Okay, so I hope that the distribution part is clear, that how distribution is happening. So the main part, the main important thing for us in distribution is what? How it happens, where it happens, and what are the factors affecting the distribution. Now there is a formula that is important, so we can see that. What is that formula? It is volume of distribution, VD. That is VD. Are you? Huh. Volume of volume of distribution. What is that? It is amount of drug in body upon the plasma drug concentration. Okay, I hope that it's clear. Nothing to do with that. Okay, but if it is higher, then definitely we can go for the actions and all. Okay, now the third part of the pharmacokinetics, that is what? It is metabolism. So what we said in the beginning, whenever a drug is going to come, what we are going to say? Adab. That is, we have taken, although we are remembering as Adab, but it is ADME: absorption, distribution, metabolism, and excretion. So now we have absorbed the drug, now we have distributed the drug. Now we have to see that after distribution what happens. See, if when once we have absorbed, then we have distributed at the different places, and now it has done its action. Now it has done its action, and then we have to metabolize it. Why? So that the excretion becomes easier. Okay, so I hope that it is understandable that why after distribution we are going for metabolism. Okay, so what is metabolism? Let's see that. Metabolism. Metabolism. So metabolism can also be called as biotransformation. Okay, or you can also call it as chemical alteration of the drug. So it now, I hope now it's clear that why this metabolism is done after the action of the drug. Because let's suppose that you have to take, there is a full bucket of water. Okay, and then your duty is, you have sent a person with full four limbs, were very well functional. The person goes, the person will take the full bucket of water because the person is capable. Okay, so it's like you have sent the drug, and the action over here you are expecting is to take that bucket of water. Okay, so after that, what do you need this drug? No, we don't need this person anymore. But what do we have to do? We have to excrete it, but we can't excrete it in that way. Why we can't excrete in that way? This is also a very important question, and we will discuss it. Okay, so why that we will discuss. So we can't remove it in its state. So what we will do? We'll take this man, we will remove the two limbs, then we'll just remove the trunk, head, and etc., and then easily this can be eliminated out. Then it can be eliminated out. So once the drug comes into the body, first absorb it, distribute it wherever you have to do the action. Then what you have to do? You have to do let the drug do the action, and then you have to metabolize it. Okay, now we know that any chemical or anything has two properties we already discussed. Let's suppose that I have a drug. Okay, this is my drug. My drug can be either lipid soluble, or my drug can be either water soluble. Water soluble, isn't it? Or else there's another possibility that my drug can be either ionized, or my drug can be non-ionized, isn't it? These are the possibilities, right? If I am having a drug, it can either be lipid soluble or water soluble, or another chances it will be either ionized or non-ionized. Okay, now our main aim our main aim is what? Our main aim is to make the lipid soluble and non-ionized drug into water soluble and ionized drug. Why? Because this is the form in which it can get eliminated. Okay, so what metabolism we have to do? We have to change a lipid soluble non ionized drug into water soluble ionized drug. I hope that it's clear that what type of metabolism is going on over here, and where it is. Okay, now we'll discuss where it is happening, but what we are doing, I hope it's clear. What we are doing in metabolism is clear. Now where we are doing, we'll be seeing that. Okay, so where this metabolism is happening? So there are sites. Okay, what are the sites? We can say the site of metabolism can be of two types. One is the primary site. Can anyone guess what can be the primary site of metabolism? Yes, is anyone willing to answer? What will be the primary site of metabolism? The one and only liver. Yes. Yes, Isha, it's correct. The one and only liver. The liver is the primary site of metabolism. And the another sites will it can be GIT, kidney, there can be lungs, blood, skin, placenta, etc. There can be these can be the other sites. But the primary site is what? The primary site is the liver, isn't it? So we started metabolism, we saw what is metabolism and what is it, and where it can happen. Yes, intestine can come under GIT. Okay, so these are the sites for metabolism. Okay, so okay, now what are the pathway of metabolism? This is interesting, so let's see the pathways of metabolism. I hope the speed is okay now. So pathway of ayo, pathway pathway of metabolism. What are the pathways? Let's see. So see, basically if you go for classical texts, then you will get only two pathway, that is phase 1, phase 2. But nowadays when like you will go for other textbooks, like the recent one which are based on the recent studies, they also have phase 3 included in it. Okay, so mainly there are two phases for the pathway of metabolism, phase 1 and phase 2, but we will also see phase 3. Okay, because it's not tough to understand, it's easier only. So now what we are seeing, how the metabolism is happening. So we saw what is metabolism, what we have to do, then we saw where it will be happening, and now what we are seeing that how it will happen. How is the question right now? Okay, so how it is going to happen? So as I said that there will be three phases. How many phases? There will be three phases. Phase 1 of metabolism, phase 2 of metabolism, and because I said based on the recent studies, based on the text based on recent studies also have phase 3. But if you go for the classical ones, there are only phase 1 and phase 2 of pathways of metabolism. Okay, now let's see what is phase 1 metabolism in detail. Okay. So, phase one. Phase one. Phase one is also called as non synthetic, or it is also called as functional reactions. Why it is called as non-synthetic or functional reactions? See, usually it will inactivate the drug. As I said, now the drug has done its action. After the distribution, once we have distributed the drug, now we expect that the once we have dropped the drug, basically dropping at the site, when you have dropped at the destination, we expect that the drug has done the work. After that, what we have to do? Now we have to inactivate the drug and we have to eliminate the drug, isn't it? So metabolism will be doing what? First thing, it will be making it into a form where it can be eliminated, or else if it can't be eliminated, we have to inactivate it, isn't it? Why? Because we don't want it, like we want us at a for a specific time period, we want a drug to act, isn't it? So after a period of time, what we expect, either the drug to go from the body, or if the drug is present, if it is not able to go, then what we have to do? We have to inactivate the drug. Okay, so the phase 1, in phase 1 what happens, it will if it is called functional reaction, so it is going to add the functional groups. It is going to add the functional groups. I hope that all of us know what are functional groups. The OH or NH2, or the SH or COOH, these are the functional groups, isn't it? So what will happen if they're adding OH and all? So these functional groups will be added. By addition of this group, what will be the ultimate thing? There will be either oxidation of the drug, or there will be reduction of the drug, or there will be hydrolysis of the drug. And after doing this much, what will happen? This drug, if it is a polar drug, I said that the if we have a lipid soluble drug, what we have to make it? We have to make it into water soluble. But if it is but if it and if it is ionized, what we have non ionized, what we have to do? We have to make it into ionized form, isn't it? So let's suppose after doing this oxidation, reduction and hydrolysis, if the drug is becomes polar, if the drug becomes water soluble, after doing all of this, then the drug will be easily excreted. Okay, then the drug will be easily excreted. But what if after doing all of this also, the drug hasn't changed its nature, the drug hasn't metabolized? Then what will happen? So let's see that. So that comes under phase 2. Now if the drug doesn't gets metabolized, if it doesn't get becomes polar, if it doesn't becomes water soluble, then what we will do? We will reabsorb it, because reabsorption is very easier for the drugs which are lipid soluble, isn't it? Because the membrane is always welcoming for lipids, so it will welcome it back, and then it will undergo into phase 2 of the metabolism. Now this phase 2 metabolism is called synthetic or conjugation reaction. It is called synthetic or conjugation reaction. Now what is synthetic or conjugation reaction? Why we are calling it as conjugation? Because over here covalent attachments are done. Covalent attachments, such as, what's that? What will be, sorry, what will be adding? We'll be adding either glucuronic acid, or sometimes we will add sulfates, or many of the things are there. There are there are in total 6, I guess. For phase 1 there are 5 parts, and for phase 2 there are 6, which we don't need to remember. They don't expect us to remember that. Okay, but there are in total 5 phase 1 drugs, sorry, not drugs, 5 phase 1 parts, such as oxidation and reduction, hydrolysis and all. Similarly phase 2, glucuronic acid, sulfates, etc. are there, which will convert the drug into what? Into a endogenous, this endogenous substance will be added, and the drug will either become inactive. Now it is becoming inactive, or it will again become water soluble, or it will become ionized. Now again it will be easier. If it is water soluble and ionized, again we can remove the drug easily. But what if it is inactive? it won't harm you. Although you haven't, if you haven't made it to in a condition when it can be removed, but you have made it in a condition where it won't harm. Okay, so I'll just repeat what I said about the pathways of metabolism. What we said is, let's suppose that this is a drug came. This drug have to go through phase 1. Okay, this drug has went through phase 1. In phase 1, we will be adding the functional groups, and this drug will be, let's suppose it is lipid soluble, and it is a non ionized drug. After phase 1, what if this drug gets converted, what if this drug can gets converted into water soluble? Okay, so if this drug gets converted into water soluble, very easy to excrete it out. But what if it doesn't get converted? Then what we have to do? Again, it will go phase 2. It will go phase 2. Okay, yeah, if it happens, very good, it will be excreted. But if it doesn't happens, then what will happen? Then it will go under phase 2. In phase 2, again, what will happen? Conjugation will happen with the glucuronic acid or sulfates or methylation. Many of them are there. Okay, after this, what we expect that either the drug will be water soluble, or the drug will be ionized, or the drug will be inactive. Okay, now if these two conditions are there, again a happy condition, excretion is positive. Okay, but if the drug is inactive, then now what we can do? And this is where the phase 3 comes in picture. Okay, yeah, this, if this inactive part is there, now we'll see that what will happen with those drugs when who is taking them, and if it is becoming inactive, then how it is happening. Okay, so here where the transport or the elimination of phase 3 comes in picture. Okay, so whenever after all of this, if a drug is not able to get excreted, then what we do, what is the metabolism? We will tell p gluco proteins to take it. Now, what this protein will do, it will literally come, hold the hand of the drug, and remove it out from the body. Okay, it will come, hold the hand of the drug, and remove it, because it has already gone through phase 1, phase 2. Now, what is this going on? Going in, over here. So this is phase 3 is basically a frustration that what the hell are you doing? Just go out of here. Okay, so it will be holding by the transporter and just removing out over there. Okay, so I hope that how this metabolism happen is clear. Okay, now I guess only 2 minutes are left, and we need to discuss a drug and its metabolism, and then consequences of the metabolism and factors that will modify the metabolism. And then we can go with elimination. So I think it won't finish in 2 minutes. So can we start another session after 10 or 15 minutes? And then we won't complete pharmacodynamics today, but we'll try to complete pharmacokinetics today. Okay, so yes, anyone have to say anything? Okay, so I'll just disconnect it, because 2 minutes are not enough to complete it. Maybe 10 or 15 minutes more is needed to complete pharmacokinetics. Okay.